So as I looked at my initial, few words, I said, maybe I shouldn't stand between this and all the great fun that's going to happen today. But before I hand over, one thing that I would like to address is the background for this entire initiative, because I get a lot of questions, both from people outside of Autodesk as well as a lot of folks inside of Autodesk, about what is this initiative all about. It all started, I think, about a year ago when during one of my trips to Stanford, I met Bill and I met Michael, and we got talking about a bunch of areas which were of common interest, both to Autodesk as well as to Stanford. The future of making, the future of learning, and some of the ideas that we discussed on that particular day still resonate in my mind. When I came back to Autodesk, the thought that was going through my mind was, gee, maybe we should do something together. Now, if you look back at all the engagement that Autodesk has with educational institutions, especially some of the top premier universities across the globe, we do a lot of research initiatives. But this is a first. This is a first simply because this is the first time we have got a bunch of researchers to come in to our premises, spend a couple of months with us, work alongside with us, understand our challenges the way we see it, and be able to learn from some of the struggles that we have faced on a day-to-day basis, look at those, and come up with creative ideas.
That this is a very unusual collaboration. Normally, when we collaborate with fantastic companies like Autodesk, it's we've got labs at Stanford and we do all this research, and it's kind of in a bubble, and there are some ivory towers that we hang out in and things. But this has really been different, to be both there and here, to be engaged with people, some of the people doing really, really interesting new software and new thinking about how do we capture what's in our imagination and make it real in the world. And this is a problem, I've been working on for a long, long time. And I think we're actually at an interesting point in human history, truly. I mean, sometimes technology just gets better and better and things get faster and faster. And it's pretty incremental. And there's a lot of buzzwords, the cloud and big data and all this stuff. But we really are at a point where I think people are going to be able to experience themselves as creative individuals, where the barrier between what I think and what I can make, what I can see, what I can visualize, how we learn, is just going to change radically, because we have the computation and the collaboration and the ability to create like we've never created before. And this collaboration with Autodesk and the work the explorers have done is all about that. It's both in education and in visualization and in basic human creativity.
The Creative Ignition Lab is really about trying to untap the potential of visual, experiential, and embodied thinkers to advance the future of learning, creativity, design, and making. It sounds like a mouthful, but it's really a good way to explain it is we're interested in everything that the SAT can't measure. Because the world is sort of focused on that and that achievement, and it feels like it leaves a lot of people out. So there's a lot of people that have a real brilliance that the world doesn't really even address how they learn or think. And a lot of people that can function in the real world would benefit greatly by having to use the other side of their brain, or being able to use the other side of their brain to solve problems and move the world forward. So our mission is really to bring the means of production and manufacturing closer to our creative space. And that's a very broad topic, but there's a lot of ways to do that. Right now, when I think of having an idea in my head and what I have to do to get it out of my mind and communicate it to someone else, to use my fingers to type on a keyboard, I think about how much I use my fingers to communicate and how much I'd like to use my fingers to create. It's really frustrating. So I'm hoping that we can drive forward the end of the keyboard in this century. Here we are trying to create a magnet for creativity and empowering people to use their creativity, to express themselves, to solve problems in the world that ordinary means might not do that. And the beauty of being somewhere in between Stanford and Autodesk is hopefully having the latitude to push the boundaries, break the rules, discover the happy accidents, do the things that you're not supposed to do, and find solutions that you never expected. And so that's sort of the tenets of the Explorer program, and you're about to meet 9 individuals that I've had the extreme pleasure of spending the last 10 weeks with. I handpicked out of over 50 applicants. I had other people from other schools, RISD, Harvard, Yale, all over the place wanting to be in this. And this part is a Stanford-only startup as far as the Explorer program to get the lay of the land. And these 9 students, or grads, were really exceptional, really motivated, and we sort of adopted the idea of a need-finding adventure as explorers and truly being explorers. And you know, the idea is not to do deep research, it's to do a wide spectrum of what's happening in the world.
10 weeks ago, I had the amazing opportunity to collaborate and meet with 8 grads and alumni of Stanford. We went through this amazing 10-week investigation, and because of our diverse backgrounds and perspectives in all of our fields, we were able to produce some really fruitful and meaningful information that you'll get to hear later today. On my end, I was particularly responsible for the community, the brand, and identity of the Creative Ignition Lab. Really, what do people really want? So we started off with Stanford alum 1 to 5 years out of graduation. And one of our big insights was that people were just as important, if not more important, than the physical resources in this lab. Another thing was that Stanford students actually wanted to be outside the bubble and collaborate with a lot of different people. So we talked to some Cal students who said the same thing. Can you see the pattern? CCA students, they said the same thing. And people in the industry, 10 to 15 years, who felt a little jaded. People who had a missed opportunity of creativity in middle school. And you know, that's when we kind of realized that this project was greater, much greater than we initially intended. And whether we come from mega corporations or small startups, we attended school, we dropped out of school, we're all here to make a greater good in this world. So the Creative Ignition community cultivates and galvanizes resources, connections, and opportunities to help everyone reach and really embrace their creative selves. So I like to tell you that the lab already exists, and the lab is in this room. You are the lab, and here are the ways you can get involved. You're already here, so congratulations, that one's done. You can be inspired by the people around you and what we're going to say. And majorly, get involved. When you go back to your everyday life, talk about the lab, invite people, get people excited, because here we are in this space, and welcome to the Creative Ignition Lab.
Well, in the past 2 or 3 weeks, we've been really doing intense interviews with Autodesk employees and talking to people who are design researchers, program managers, directors, VPs, and one of the most insightful conversations we had was with Erin Brander, who's a design researcher within the Dreamcatcher group, which I'll explain a little bit about later. But what she said was that experts have a very precise way of speaking when they use a certain tool, and that becomes their core language, their mode of operating. In the case of something like AutoCAD, people think about things in lights and dots. And so what we wanted to explore was, how can we categorize, how can we identify what people are doing with their software? And we did this by a focused exploration. We divided users into 3 classes. One in which they were looking at something like AutoCAD, where they're looking at lines, when they're using lines and dots. We looked at people who were using Revit and Inventor, where they're using planes and surfaces. They would also use Dreamcatcher, in which they're using goals and constraints to define what they're doing. And really, if you look at each of these examples, you're seeing very clearly that the approach they're taking is mediated by what they have with the software. And so if they have lines, they see lines when they're prototyping something. If they have planes and surfaces, they see a rectilinear model of what they're thinking. And if they have goals and constraints, they see fluidity and they see movement happening through algorithms, right? And Bill calls this to some extent giving yourself up to the software.
A mantra found in Dreamcatcher that one goes out there and you would take in as much inspiration as you can and knowledge, generate some sort of models based on these constraints that you've come to understand, and then explore that space until you find something that is exactly optimal, and then you fabricate it. And the key word here is actually flow, right? It not only describes, I think, the psychological process associated with this, but also a large-scale movement of design.
So what is flow? And how does flow matter in the design process? We asked ourselves this question to gain our ground and think about what our lab was doing as a whole. And for the first 7 weeks of this 10-week program, we did a massive amount of interviews with people who were designers, educators, modelers, lawyers, and one of the best conversations that I had was with a yoga master, per se. His name is BK. He's a founder of the Naroga Institute, which is a program that teaches or reaches out to inner city youth to help them regulate their emotions and their logic. And the goal is to have them essentially understand what creativity is. And it turns out that creativity, according to BK, is really having a state of relaxed attention. And what I mean by that is being able to, one, take a breath, look at a problem, look at it in a great scope, come back, focus on a goal, and then create something out of that. And that is relaxed attention. That is his definition of creativity. It's a process. It's not about the end product. It's about what you're doing to get there.
We found, talking to a professional musician, that they described flow as the unmediated transfer of one's essence and intent out into the world through the medium of music, right? And so I think this is understood as a process of translating both through the instrument and what the instrument itself affords, right? A saxophone isn't exactly going to do what a piano does, what a trombone does, what a violin does. And similarly, we found, looking at some of Bruce Beasley's work, and as well as this quote where he says, "I want to take the ideas in my head, remove any material limitations, and give them life," that, well, this is what happens when he picks up various instruments from Autodesk and elsewhere, that you can see that the actual shapes, the actual form and function of these things, well, resembles the tools from which they came. And so what we wonder about and what we've really been exploring is this process of creation, and that what happens when you have to deal with dots and lines or planes and surfaces, or with Dreamcatcher in the future, the processes of life.
And what we really want to do eventually is acknowledge that the design process is actually something that needs to happen earlier on in the education system. According to BK, who we interviewed about creativity, it's not taught. Flow is not taught. You are not taught how to manage that emotional, logical, body language process, right? Imagine the software like Dreamcatcher being able to teach a student how to intuitively model their flow, right? That would be an amazing world. And to talk more about that, we have Xander, Michaela, and Kelsey to explain more about the embodied immersive experience. Thank you.
We're looking at open-ended learning environments, and in particular, how big a part uncertainty and ambiguity play when you're learning something creative in particular, but in learning environments, those are really important themes that we found through our early research, flexible thinking being such a big part of when you're fully engaged in this simulation. How are you going to deal with these problems that don't have necessarily defined statements of the problem? And so we were looking at how to get from these open-ended scenarios to this creative thinking and the confidence to think creatively. And Michaela was really a bridge for us in connecting the open-endedness to this creative confidence with her focus on resilience and how when you hit a barrier, are you going to pick yourself up or are you going to feel defeated by that? And that's such a big deal when you're talking about uncertainty and ambiguity, because those are constants. And so we were really motivated to look deeper at this kind of ability for uncertainty and ambiguity to be an empowering kind of bridge to a more creative state of mind, or if it would be a barrier to kind of be discouraging.
So for our research question, we wanted to look at how learners respond to different levels of structure in challenges.
Yes, and to do this, we came up with 3 Lego build challenges. So our first level was a step-by-step instruction booklet. So we asked people with a limited number of bricks to build through the instruction booklet and end up with a hovercraft vehicle in the end. The second was still a limited number of bricks, but a more open-ended goal. So we asked people to build a tower, but in this case, it was totally up to them about how they're gonna reach the top of the tower. We gave a height requirement, but beyond that, it was completely up to them. And the third was totally open build. So that's when we gave people the full box of bricks. They could build whatever they wanted. And when we did our testing, we worked with middle schoolers. We had the awesome opportunity to work with 10 great middle school students. And we wanted to work specifically with middle school because we found it a really interesting time of transition. It's a time of a lot of identity formation. It's a time when students are deciding for themselves what they may or may not be good at.
So we learned something from all 10 of the students we worked with, but today we're going to focus on 4 who led us to really interesting discoveries. So the first was a girl named Amanda. She was particularly into the tower challenge and really blossomed under this circumstance where she had a goal and was trying to achieve this goal. And she objectively did very well and really blossomed with the success. She was able to not only build the tower to the height, but actually hold, that's a full water bottle. So she did extremely well, and she became incredibly confident through this challenge. In contrast, we had another student named Justin who, I want you guys to look really closely at what happens when he engages with the challenges. So at first he was pretty interested, excited, but then as he started to build, his tower just wasn't standing up. He started to get a little bit doubtful. And then he began to disengage. He, especially looking over at his brother and seeing that his brother was doing well, he was really struggling. And then when it came time for the creative challenge, he actually didn't have the creative energy to build anything at all. And that was really interesting to us, that this initial challenge had this impact on his creativity on a totally separate task. And meanwhile, his brother Jordan, who you saw in some of those earlier shots, was actually getting a little bit of boost from this comparison. So if you look at these, you can see they're constantly looking at each other, constantly comparing. I'm sure anyone who has siblings or kids would understand this. But it was just interesting to see that even though Jordan wasn't maybe doing as objectively well as a kid like Elena, he actually was becoming incredibly confident because he could see himself succeeding where his brother was struggling. And at the end, because he had this confidence, because he felt like he was good at this, he was doing well, he became incredibly proud and possessive of this object that he had created in a very short period of time. So he made this little ship, and he didn't want to disassemble it. As we were cleaning up, he was sort of like going around the room, like hiding it from us, until at the end we finally let him put it in a box rather than disassemble it. So it was just interesting to see how quickly he earned that ownership of that. And finally, we had a student named Emily who we're really excited about, and I want you guys to just sort of take a minute to see what she did during her build challenge.
Thank you. Oh my goodness! Good. Not real. Oh, phew. I mean, oh my god!
So you can see this girl just did not quit, and no matter how many times her tower fell down, she persisted. And when she finally got to the end, you can just see that pride and accomplishment on her face. And so we got really interested in that question of what made her persist where other students might decide to give up.
At the beginning, looking at Amanda and Justin, we saw with them that their early reaction to how they were doing created this attitude that was either based on, in Amanda's case, doing objectively very well, maybe something we're familiar with, I got a great score on my test, or I held up the whole water bottle full of water. She felt good because of that, whereas Justin encountered some problems, and for him, just the comparison about his brother being next to him and doing better also gave him a similar kind of attitude that then turned into an early identification with Amanda. It was, I am really good at this. She was feeling great about her abilities with Lego, whereas Justin pulled back and completely disengaged and had this identity of, I'm not good at this, this is not something I can do, and completely disengaged from the project at that point.
Michaela also mentioned Jordan. We are really interested to see how protective he was of this vehicle plane that he had built 10 minutes ago. And so we were really interested in pursuing this idea further of like this type of ownership that comes together from this student's own personal goal, which leads to our last insight about the self-directed goal. So Emily was just kept going, and she had this really strong desire to connect two spiraling staircases, and it kept breaking and it kept breaking, and it was almost as if those discouragements were lighting a fire under her to finish off, and we really think it's because it was her personal goal that she had developed for herself. Moving forward, we are really interested as a lab about how we're going to develop more learners to be like Emily. How can we facilitate environments that help people gain the resilience that Emily had? And so that's what we're really curious about in our future directions. All right.
This is not a design tool.
This is not a design tool.
This is not a design tool. Actually not, maybe. All right.
And the curiosity that ignited our exploration was how might we create an intuitive interface that would be closer to a design tool enhancing the maker's creation to ideation process. The problem is simple. The way that we make things in the digital space is just not how we make things in the physical world. Because our mission was extremely human-centric, we first just spent hundreds of hours talking to individuals who make stuff. We talked to software engineers, architects, cooks, and even kids. We found that makers really value simplicity in tools. Makers who were prototyping with a medium preferred to explain detail very conceptually instead of making an overcomplicated model. We also found that makers really value movement. People really want to seamlessly translate their physical creation into the digital space instead of learning some machine command and sitting behind an uninspiring computer desk. In fact, creativity was often sparked in this physical journey in which the imagination met the constraints of reality. Finally, makers really valued their third eye. A lead UX designer here at Autodesk expressed her wish for the interface of the future to be invisible and tapping into this third eye. Neuroscientists recognize this third eye as rapid cognition, when we think really quickly, and this is based just on our experiences and existing knowledge. So as we gathered all of these insights and started to notice the relationship between them, we were then inspired to seek what exists today in the world that is tapping into the maker's intuition.
So we took a look at several pieces of technology, and each of the ones that I'm going to display has a certain feature that can be used to inform this ultimate user interface that enhances the maker's process. So here we have Microsoft HoloLens, and it allows you the ability to choose from pre-selected basic 3D designs and then build upon those. Here we have Handy Potter and Leap Motion. So you can use these two technologies to use natural hand motions to create your objects. Here we have Claytronics. So using nanoscale technology, you're able to physically manipulate this car model in real time. So all of these technologies and our early insights led us to create a prototype around just one of these features that will enhance the user interface. So we chose being able to model 3D objects using natural hand motions in real time. So now I'll show you guys a video of our prototype. So you see the user making natural motions above the screen, and then below we have a simulator acting as the software, mimicking whatever changes the user makes in real time. And from this prototype, we were able to gain further insights.
One of the first things we ran into was the split between art and tech and what their requirements were for an interface. And we realized very quickly that this was mainly due to the more explorational nature of the artistic design process in contrast to the more parameter-driven technical design process. Another thing we quickly realized and heard from anyone from sculptors to engineers was how natural it felt to actually work in 3D space. And there's so many strong things that connects us to our spatial environment and the spatial feedback that we get with our mind and body connection. And we think that these tools, which are extremely powerful, are currently being totally disregarded in the current interfaces and really should be used as much as possible. Another thing we came across, especially during our prototyping, was the minute where people were playing with the Play-Doh, when they ran out of things to do with their hands or they just couldn't command it, they started actually giving vocal commands or showing gestures. And we really feel these two can be really strong tools that can replace a drop-down menu as we move forward. When we initially started with this idea of what can be an intuitive interface or what could be the ultimate interface, we thought, okay, if you thought of an idea and it materialized on the screen, how wonderful would that be? But we quickly realized that actually design is a very embodied process, and you kind of need to make this thing, you start with a very fuzzy idea, and it needs to become more physical through an iteration, and you have to go through that to refine it and make it into a form or a product. So the interface really needs to capture that process as well. And last but not least, it was almost our pleasant surprise to see how we really crave for that human touch and even the non-human. While we were doing the prototype and this person was imitating to be the computer, the little laughters and that playful environment really made some of the failures much more enjoyable, and it kind of created a much nicer environment than dealing with a kind of error box on your screen that says, like, cannot compute or cannot do whatever, iterate. So we really feel this kind of more human interaction can create a much better environment and much more better experience for the people designing and making. As we kind of generate more technology that opens more path for new design tools and creative exploration, we really have to start abandoning this search for what the computer can do and start looking into what the human can do.